Hey guys, and welcome back to Study Journey. It's Mary and I'm back with another AMC 10 problem. This is going to be about finding the area of a triangle with the restrictions given about a circle, and we're going to be using the Shoelace Theorem. So if you don't know what that is, keep on watching and we'll solve it together. So without further ado, let's get on with the video. This is AMC 10A problem 21 of the year 2016. Circles with centers P, Q, and R, having radii 1, 2, and 3, respectively, lie on the same side of line L and are tangent to L at P', Q', and R', respectively, with Q' between P' and R'. The circle with center Q is externally tangent to each of the other two circles. What is the area of the triangle P, Q, and R? Here are your answer choices, and let's look at some keywords. So these three circles have the radii 1, 2, and 3, respectively, which means P has a radii of 1, Q has a radii of 2, and R has a radii of 3. And then it says they lie on the same side of line L and tangent to L at P', Q', and R'. And it already tells you that Q' is in between P' and R', and that the circle Q is externally tangent to each of the other two circles. And it's asking you the area of triangle PQR. Remember that when we are doing geometric problems, we should always try to draw a diagram that is as accurate as possible. Okay, sorry this isn't the best diagram, but you get the idea. Here are your circles P, Q, and R. Here's the line L, and here's where it is tangent to line L. And the radii is 1, 2, and 3, and I drew the triangle. So how do we find the area of this triangle right here? We're going to be using the Shoelace Theorem. Shoelace Theorem basically says that we can find the area of any given triangle if we know the coordinates of the three vertices. So if we can find the coordinate of P, Q, and R, let's make a coordinate plane by ourselves and find the three coordinates, then we can find the area of triangle PQ and R. So to set up the coordinate plane, let's let P' be 0, 0. So this is the origin. Then we know P's coordinates will be 0, 1. So this is the origin, this is 1, then this will be 0, 1. Now we just have to find Q and R. Well, because we already know that Q to Q' is 2, then to find the coordinates of Q, we just have to know what P' to Q' is. Or this will be the X coordinate and this will be the Y coordinate. And we know for Q, the Y coordinate is already 2. So now we just have to find the X coordinate. The X coordinate is P' to Q'. So we can use the Pythagorean theorem. We know that this right here is a trapezoid because these two are parallel. So let's draw this out in a more precise diagram. If this is P, this is P', and this is 1. We know that Q to Q' is 2, and these two are perpendicular. This is 1, this is 1. Well, we can note that since the radius from here to here is 1, and from here to here, since they are tangent, that is 2, then we know that PQ is 3. And since PQ is 3, using the Pythagorean theorem, we can tell that P', Q', or this line right here, would equal the square root of 3 squared minus 1 squared, which equals the square root of 8, which equals 2 times the square root of 2. So the coordinates of Q would be 2, square root of 2, and 2. Now, we can use the same exact thing for R. Using the trapezoid Q', R', we can make it into 3 segments where these two are relatively 1 and these 3 are 1 because we know this radius is 3. Now, since we know this is 2 and from here to here is 3, the radiuses, then we know that this is 5. Q', R' would equal the square root of 5 squared minus 1 squared, which equals the square root of 24. And then we can simplify that to 2 times the square root of 6. So R would be the segment Q', R' plus the segment P', Q', because remember this is the origin. So this will be the X coordinate and this will be the Y coordinate. So the x-coordinate would be p prime q prime, which we already know is 2 times the square root of 2, and then plus the segment q prime r prime, which we solved is 2 times the square root of 6. And then the y-coordinate would be 3. Now, we found the coordinates for all 3 points. Now we can use the Shoelace Theorem. So the Shoelace Theorem is actually for any polygon. So a shape with any number of sides, you can use this theorem to find the area of the shape. This states that the Shoelace Theorem states that suppose polygon P has vertices A1, B1, A2, B2, and all the way to how many vertices, or A and B. Then the area is 1/2 of the absolute value of A1, B2 plus A2, B3 all the way to A and B1. And then you subtract the sum of B1, A2 plus B2, A3 all the way to B and A1. This is called the Shoelace Theorem. When you can see from here, if we cross add it, then we will get this. So it looks like a shoelace. A1, B2 right here, A2, B3 right here, and all the way to A and B1, which is right here. And then you subtract B1, A2, which is right here, B2, A3, and then etc. Okay, so how do we use this? Well, when we are using this, we already know that here are the 3 vertices. So we know the coordinates. A1, B1 would be like 0 and 1, A2, B2 would be 2 times the square root of 2 and 2, and etc. So since we know this, then we can just plug it in for this to find the area. So the area would equal 1/2 of the absolute value of A1, B2. So A1, B2, 0 times 2, and then plus A2 times B3, A2 times B3, 6 times the square root of 2, and then plus A3 times B1. And then you would subtract B1 times A2, add B2 times A3, and then you would add B3 times A1. And then remember, this is the absolute value. So let's simplify and find the absolute value. And since we know the square root of 6 is greater than the square root of 2, then we would simplify this as 1/2 times, and then we would get the square root of 6 minus the square root of 2. And that would be your answer. So looking at our answer choices, we can tell that the answer would be D, the square root of 6 minus the square root of 2.